In this video, we're going to talk about graphing exponential functions. Whenever we're dealing with exponential functions, we have two types. We have growth and we have decay. We're going to look at growth first. So your basic graph for growth will look like this. Your function should be growing, and it should be growing very, very quickly. Your parent function is y equals b with an exponent of x. This b is just representing a number, so it could be any kind of number here, and your exponent will always have a variable of x in it. This type of graph is an exponential graph. This word asymptote we haven't seen before. An asymptote is a line that your graph gets very, very close to, but never quite touches or crosses. So in this case, our asymptote is going to be on the x-axis. I'm going to draw it in here with some dashes. You'll see that our blue line is getting very, very close to this dashed line. It's almost going to look like it's touching it, but in fact, it never quite touches it. It just gets very, very, very close to that asymptote. Because my asymptote was a horizontal line, it should be y equals, and it looks like it's crossing at 0, so it's y equals 0. For intercepts, we'll write down anywhere that this graph crosses the x or the y-axis. Because my asymptote is on the x-axis, it should never cross, but it does look like it crosses the y-axis at 0, 1. What's nice is that exponential decay follows a similar pattern as exponential growth. A big difference you can see in the graph is that things are now moving downwards as they're decaying, so they're not growing, but things are getting smaller. Your parent function for exponential decay is the same as exponential growth, so y equals b with an exponent of x. This is still called an exponential function, so the type is also the same. I'm going to look for my asymptote on the graph. It looks like, again, things are starting to flatten out right here at 0. So my asymptote is at y equals 0. Looking for intercepts, again, it's never going to cross this line, so it won't have an x-intercept, but it does cross the y-axis at 0, 1. The first two graphs that we looked at were quite boring. They didn't have a whole lot of movements. Things didn't move left and right or up and down at all. So the next thing we'll talk about are transformations. What's nice about our exponential functions is the transformations are the exact same ones as we've seen with quadratics and with square roots. So I want to start with reviewing all of those. The first thing that you want to look for is your b value. That is your base, so it's right here. Your base doesn't really give you a transformation, but it does tell you whether things are growth or whether they are decaying. Okay, if you have a growth function, this b value will be a whole number. And if it's decaying instead of growth, this will be a fraction. It's a lot easier to look at that base to figure out if things are growing or decaying than it is to look at the graph. Your a value will tell you whether there was a reflection. You'll know that there is a reflection if there's a negative out front. It also tells you if there was a vertical expansion. We'll abbreviate as VE. A vertical expansion is given by a whole number. And you could also have a vertical compression, which is given as a fraction. Sometimes you'll see a plus or minus number next to this x value. That plus or minus number will tell you how far things go to the left or to the right. This is always opposite, so if it is going to the left, it'll actually be a plus sign, which is weird because we typically think of left as moving negative, but it's opposite. And if it's going to the right, it will be a minus. The last thing you'll look for is this number on the end, so this is not part of the exponent. This tells you how far things go up or down. This is not opposite, so if it's going up, it'll be given as a plus sign, and if it's down, it'll be given as a minus. Okay, let's go through example 1. Gives me 2 with a base of 1/3, exponent is x plus 7, and I have a minus 3. I like to kind of go just in order from left to right, talking about each of these numbers. So the first thing I see is a 2 out front. That 2 tells me there is a vertical expansion by 2. This 1/3 doesn't really tell me a whole lot transformation-wise, but it does tell me that it's decaying. Again, I know that it's a decay function because that 1/3 is a fraction. The next thing I see is x plus 7. The plus 7 is telling me that I'm going to the left 7. And the minus 3 tells me that I'm going down 3. Go ahead and pause your video and try example 2. If you didn't quite get example 2 correct, please take a look at the transformations that we have written here. Make sure that you're thinking of the reflection and the vertical compression as 2 separate transformations. Right 9 is opposite of a minus 9, and the plus 12 gives me up 12. The problem didn't ask for this, but you might have also wanted to say whether this was growth or decay. Because it's a 5, which is a whole number, this is an example of growth. These next couple examples are going to have us put together everything that we have learned. So we are going to graph the function that they give us here. We're going to write down our intercepts, our asymptotes, our transformations, and figure out whether it was growth or decay. I'm going to start with just drawing in my x and y axis. And when we're going to graph it, we are going to use our calculators. So whenever I'm graphing on my calculator, the first thing that I want to do is go to my graph, which is y equals. From there, I'm going to plug in the equation. So I have 2 with an exponent of x. Make sure you hit this right-hand arrow to bring you down. And then I can type in the plus 1. Once everything's typed in, I'm going to hit graph just to get kind of a general idea. If you get something wacky on your screen, just go to zoom 6 for standard, and it should bring you to your graph here. Now, I want to find some nice points to graph, so I'm going to go to second table, and it'll bring me a table of all these points here. Now, I'm kind of seeing a lot of 1s, looks like some decimals, so I'm going to pick just some nice points. These are really far, so let's keep going. 0, 2, that looks like a nice point that I could graph. So 0, 2. I'm going to keep scrolling here. 1, 3, I can also include. So right 1, up 3. 2, 5, 1, 2, 1, 2, 3, 4, 5. And then I'm going to go back to my graph so I can kind of see. It looks like it's going to keep going up, but it does look like it's flattening out here. So there is my graph. Not perfect, but it's good enough. Intercepts. I can see that it crosses the y-axis here at 0, 2. That was one of the points that I included. My asymptote is where things are going to be flattening out. I always like to draw it in my graph. One tip is that your asymptote is always going to be this last number here. So because that was a 1, I know that my asymptote should be at positive 1, which follows exactly what my graph looks like. So my asymptote is at y equals 1. Transformations, I need to list what happened here. This 2 didn't really give me a transformation, but because it's a whole number, it tells me that this was growth, so I can go ahead and circle that. Next to the x, there's no plus or minus, so it didn't go left and right at all. And then I just have a plus 1, so this went up 1. All right, the next one here, again, we're going to start with graphing it. So I'm going to go back to my y equals. I'm going to clear out everything that I have and type in this guy. So I have negative And then my base is 1/2. I'm going to put that fraction in parentheses. Use my caret button to get up to the exponent and do x minus 2. I like to hit graph to get kind of an idea of what it looks like. So it looks kind of like it's going up this way this time. To get to my table, I'll go to second graph. So I have one point at -1, -8. 1, 2, 3, 4, 5, 6, 7, 8. I have one at 0, -4. 1, -2. -2, -1. And then I'm getting just kind of some decimals here. So I'm going to draw in kind of what I'm seeing. And I'm also going to include that asymptote right away because there is no number on the end. Like on this one we had that +1 on the end. There's no number on the end here, so this is just at a +0. So I'm going to draw it in here at 0. My intercepts, one of the intercepts was at 0, -4. My asymptote we just found at 0, so y equals 0. I have a little bit more happening here with these transformations. My negative out front says that there is a reflection. The 1/2 is my base. It's a fraction, which tells me that it's decay. I had a -2 next to the x, so that tells me that I moved to the right 2. I do want to point out just real quick that when you take a look at part B, it looks like it's moving upwards. So at first glance, you might want to say that this is growth. It's really, really important that you look at the base when you are trying to figure out whether things are growing or decaying. This is still technically decay, even though when you look at the graph, it looks like things are moving upwards. For example 3, why don't we graph this one together and then I will have you guys try to fill in these characteristics on your own. So we're going to graph first, which means I need my calculator. So I'm going to go to my y equals and clear out what I see, and I'll type in the graph. So I have 2 with my exponent of x plus 3. And then scroll over, and I have the -5. I'm going to jump right away to that table. So second graph. And I can start my sketch. 111 is kind of big. I'm going to skip that one. 0, 3 I can definitely put. -1, -1. -2, 1, 2, 3, -3, -3, 1, 2, 3, -4, and then I'm getting to some decimals. So my guess is I'm going to go to my graph here just to make sure. Again, I can look at this last part to figure out where that asymptote should be. So it should be at -5. So I'm at 1, 2, 3, 4. I need one more here at -5, and then I can draw in that asymptote. So it looks like my graph should be doing something like this. Go ahead and pause. I want you guys to try and fill in the rest of the characteristics. All right, here are the answers to those characteristics. The intercept was at 0, 3. It was up here at 0, 3. My asymptote was at y equals -5. So going across here at -5. Transformations, we went left 3. That came from the +3 with the x, and down 5, which came from that -5. And the 2 was the base, so it just told me growth. Make sure that you're not thinking of that 2 as a vertical expansion. whatever number is closest to the exponent, so this one's right by that exponent, that just tells you whether growth or decay. It is not telling you exponential, or I'm sorry, it's not telling you vertical expansion or vertical compression. I would go ahead and write down A and B for example 3. Go ahead and try them on your own, again using your calculator to graph both of them and then writing down those characteristics. I'm going to put the answers up, but I highly recommend that you try them on your own first. Alright, here are the answers for A and B. A should have been pretty straightforward. After you graph it in your calculator, you can find these 3 nice points. We know that my asymptote is at positive 7 because of this plus 7 on the end. We had an intercept at 0, 6. The asymptote, that straight line, was at 7. We had 2 transformations. The reflection came from this negative. The 3 was just the base, so that told me that it was growth because it's a whole number, not a fraction. And the plus 7 told me up 7. Again, a common mistake is to say that this would be decay because it's moving downwards, but it's actually just growing negative because this 3 is a whole number, so it's got to be growth. Part B was a little bit trickier. Once you plug it in, you can only find 2 nice points. But we should know that the asymptote is at negative 3 from this negative 3 here. I personally thought that the intercept was kind of weird. I noticed that I didn't have a nice point for either one of my intercepts there. So when you go to your calculator and you go to your table, so second table, it'll show you that intercept when you find x. So when x is 0, it gave me a y value of negative 2.875. That should be this point right here. So don't freak out if you didn't have a nice point on that y-axis. You can always find the y-intercept from your calculator. Your asymptote should be at y equals negative 3. You had a couple transformations this time. I have a vertical expansion by 2 that comes from this 2 up here. Your base was a 1/4, so that told me it was decay. Fractions are always decay. Plus 2 told me left 2, and a minus 3 told me down 3.